The diagram shows a rectangle inside an isosceles triangle. The base of the triangle is n times the base of the rectangle for some integer n greater than 1. Prove that the rectangle occupies the fraction 2 out of n minus 2 out of n square of the total area. So I will start with naming the figure. So I can have this as A and B and C. So because this is one small triangle ABC and the larger triangle ABC, so I get D and this is E, F, G. So those are all the vertices named. Now you see the triangle ABC would be similar to the triangle ADG. So right hand triangle ABC is similar to triangle ADG. It's very obvious because angle A is common, and of course angle ABC equals angle ADE because the triangle is isosceles and BC is of course BCEF is a rectangle, meaning BC is parallel to EF and so on. So obviously triangle ABC is similar to triangle ADG. So once that's done, the next thing I'm going to do is I'm going to draw a line which is going to be the height of triangle ADG. So I draw this line. It should be a straight line, but my line is a bit wavy. But so this, I'd call it AX. And I will say, and this point is Y. So I will say that let AY be equal to small a. So I am saying this is small a, and let BE be equal to Y, and let EF be equal to X. So let AY equals A, and let BE, or sides of the rectangle, BE equals CF, and that equals Y, suppose, and EF equals X. So we can say that the base of the triangle is n times the base of the rectangle. So therefore DG should be equal to NX. So this is DG. So this whole thing should be equal to NX. And that would mean that FG is NX minus X out of 2, and DE is also NX minus X out of 2, or NX minus X out of 2 can be written as N times X minus 1 out of 2. So I will say, anyway, we'll do that later. So that's the thing. Now what we do is we use the property of similar triangle to work out the lengths, the ratio of these lengths. So we see that we know by using the property of the similar triangle that BC divided by DG, so BC divided by DG should equal AX divided by AY, this is Y. So AY, not AX. AY divided by AX. So BC, I know what it is. BC is X, because BC is EF is equal to the small x. So I'll say that x out of dg, so dg is nx, and that equals ay is a small a out of ax, so that's ax. So ax would be a plus y. So we can say from here that 1 out of n equals a out of a plus y, or a plus y equals a n. So I can say y equals a n minus a. So y equals a times n minus 1. So this fact I'm going to use. So y equals a times n minus 1. So therefore, the area of the rectangle should be xy. So I get x times this. And so I can say, so if I area of the rectangle, choose another color. So area of the rectangle equals xy, and that equals x times a times n minus 1. Okay, so x a times n minus 1, this is the area of the rectangle. Now what is the area of the triangle ADG? An area of the triangle ADG would equal half times base times height. So half times base, which is nx, times height, which is a plus y. So instead of y, we write a plus a times n minus 1, because that's y. Because this is y. Not this, sorry. A plus y, this is y, isn't it? This is y. So yeah, I think, let me make it clear. It won't be clear to me either. So area of triangle ADG is half times nx times a plus y. That's the height, a plus y, because this little bit a and it's this y. So then that we can rewrite as half nx times a plus y is a plus n a times n minus 1. And you see this can be written as half a taking outside the bracket nx and then a outside the bracket. If we did write it as 1 plus n minus 1, and the 1 and 1 cancel, so we get half n square xa. So that's the area of the triangle. So we need to know the fraction the rectangle occupies, a fraction of the total area. So the fraction of area of the rectangle, so area of rectangle divided by area of triangle, that would be the fraction, required fraction. So if I say required fraction, which is area of BCEF rectangle divided by area of triangle ADG. ADG. And here the rectangle is BCEF. Okay, so just to make it very clear, so the required fraction would be xa times n minus 1 divided by, or I can say, anyway, I can write half n square xa. So we are left with, that would equal, the x and a cancel out. So x and a cancel out. And we are left with 2n minus 1 out of n square. And that is 2n out of n square minus 2 out of n square, and that would be 2 out of n minus 2 out of n square, and that is exactly what we've been asked to prove. So that concludes our proof, and this is the answer, or we can say proved.